Before I get started, I just want to say this ahead of time. I started learning Vulkan a long time ago, and then I stopped because I got busy with life. Then I started learning it again. I tried learning C++. I really just thought C++ was really just pointless. And I didn't see any examples in C, and it got me extremely frustrated. So I used AI to look at examples in C, so I wouldn't have to look at all this C++ code that I really think is unnecessary. Yeah, and I'm not claiming to be an expert. These tutorials are just what I learned. I'm not saying I'm an expert in graphics programming. This is just from what I've learned within, I don't know, a few weeks or so. I have had a lot of experience with STL. I made a lot of little short games in STL and stuff like that. I kind of used OpenGL, but not a lot. A lot of people say not to learn Vulkan because it's too complicated. But I kind of like knowing extra stuff. So I'm kind of more inclined to want to learn Vulkan because I want to know all that weird nitty gritty stuff. Some people think it's a waste of time. I don't think so. I've enjoyed all of the stuff I've been learning and all the extra stuff. I don't think it's that complicated. It's a lot of steps. But as far as too overwhelmingly complicated, I don't know. It hasn't seemed worse than OpenGL to me, at least thus far. All right, so from the last video, I made a few changes. I renamed create swap chain to be camel case. I used print error here instead of printf. I made a free swap chain function, made some spaces in between the equal signs. This is just moving things around a little bit right here. This here, just moving things around, making spaces. Created a bool for found instead of an int, and then use my free swap chain function at the end instead of doing the two free statements. I'm also going to add this for loop inside the free swap chain function. I'm going to make sure to put the I variable outside of the for loop because you can't declare it inside of the for loop in C89. And then I honestly replaced the if and then print error statements with just assert, only because I just got tired of looking at all of the printf, exit, and whatever. And I don't know. I just feel like it's probably cleaner just to do the assert at this point. So I originally, when I was starting to make this, I was doing that, and I'm like, you know what? I want to be more descriptive on my errors. And now I'm just like, I can look at the line number and see where the code is at. It just looks a little bit nicer. I'm going to be going over command buffers, and really the Vulkan documentation does a pretty good job at describing this. I also want to note that I am going to add a little bit extra code only because in the future we're going to use dynamic rendering. So I'm going to keep the dynamic rendering thing here. But just keep in mind that if you want to draw a triangle to the screen, you don't actually have to write as much as I'm going to write. But I assume you also probably want more than just drawing a triangle to the screen. So that's why I'm going to skip the some other things. So let's keep in mind, while we're making the command buffers, there's different states for the command buffers. There's the initial state, the recording, the executable, the pending, and invalid state. We're going to walk through this more as we write the code, but I'm just giving you text from the documentation. All right, so let's make our vk command buffer and vk command pool global variables. Let's create our create command pool buffers function. Then I just swapped out the if print error statements for assert, I made a free command pull buffers function as well, so we can make sure to free the memory appropriately. Then I'm just going to add at the end, so we can remember free command pull buffers. All right, so in our create command pull buffers function, we make an info struct for our command pool. We're putting our queue in here. We're gonna create the command pool. It'll fill in that variable we had earlier. We're gonna allocate the command buffers, which we're gonna allocate a command buffer for each swap chain image. Then we're gonna make get our struct here so that we can allocate our buffers, and we're going to make a primary buffer. So there's differences between the primary and secondary buffers. Those are the two kinds of command buffers you can have. The primary are the top level buffers. They can execute commands directly like vk draw, and also call secondary buffers to execute, and they're independent, self-contained. When you start recording in a primary buffer, you must define the entire state or inherit nothing. At least that's what I'm reading here. But yeah, so this is just going to be the primary buffer. Then we get the count of command buffers that we're making, and we're going to allocate them. And when we allocate them, we're going to put the buffers in the init state that we mentioned earlier. Command buffers in the initial state can only be transitioned to the recording state or freed. When a command buffer is allocated, it is in the initial state. So yeah, we're putting it in the initial state here. And then I'm just gonna call it down here, create command pool buffers. And it's not really gonna do anything because we're not gonna be using them, but I'm still gonna call it here. And real quick, something I forgot to do was put a vk destroy command pool in the free command pull buffers. And I'll just do another make clean make run. Seems good. Yeah, that's gonna be all for now. I'm gonna have to go over the graphics pipeline next, and then we're gonna have, after that, we'll record into the command buffers. But I want to state this as well, like a lot of these videos are really just for myself, to be honest. But I figured it would be a creative way of me making content so I can remember this, and also maybe it helps someone else. So there you go. Yep, so that's it. Next time I'll go over the graphics pipeline, and then we'll record in the buffers, and then hopefully after that we'll have a triangle, and then we'll also after that get some vertices on the screen, and then, you know, get some meshes on the screen. We'll do some textures. Yeah.